وصلنا Janina. Good. Ya Jabula. Ya Jabula uni bona la non tangi. Non chiede chiede mai per cosa. Ma the do something to pay my view is finished, and now I'm going to have to speak English. Okay. Right. Right. We're going to start as we always do. We're going to start with a prayer. If we can keep it called. Again, we can just bow our heads and close our eyes. Thank you. Father, we thank you for these learners. We thank you for their social around here. We just pray that you would bless our time together, that it would be productive, and that we would shine the Bible. We ask all these things in your name. Amen. Now, guys, just to shine the Bible. Come here. Okay. This is my friend Camilla. She's going to help me today. And this week, she's going to walk around with a microphone to get some answers from you guys. Okay. So that I'm not doing all the teaching. Okay. Right, the topics we're looking at today, they the first of the term one topics. So they things like exponents, equations, inequalities. This stuff, okay, it's very, very important. Okay, and this math, this exponent stuff and everything is what everything else is going to rest on. Okay, so I'm going to ask you to go to page 3, your first page. And I'm just going to ask Camilla to find a learner who can just tell me, what does this mean? What does this mean? What does x cubed mean? Just give the microphone to anyone, Camilla. Because if you wait for a hand to go up, maybe come guys, don't be shy. Let me tell you, one day you're going to go for a job interview and they're going to say, hi, how are you? Ubani Gamalak. No, okay. They're not going to give you the job. You must say, hi, I'm Paul, I'm really young. Yeah, someone tell me, what does x cubed mean? Okay, you don't have to stand up, but it's fun. Thank you. Hi. 3 x's. Like 3 x's. No. What? Like x. Okay, now you're saying times. Yes. Okay. So x times x times x. Hello. No. Okay. We more than that. Okay. Okay. And so let's just have a look. Someone else can maybe tell me, what does this mean? You don't worry to stand up. Don't worry to stand up. How what?
It means 3 x's.
3 x's. Okay. No. Guys, this is very important, right? Because okay, x 3 x's adding together, x plus x plus x. Hello. Okay. All right. They are different things. Okay. This here we say x cubed. All right. Sometimes my learners, if I write something like this, they'll say x5. Don't say x5. Okay, because x5, then we're not sure, does that mean 5x or this? We're going to write, we're going to say x to the 5. X to the 5. And what does x to the 5 mean? It means x times x times x, 5 of them multiplying together. Does it make sense? You see, maths makes sense. It all makes sense. Guys, this stuff did not come down on stone tablets with Moses, with the commandments. Math, was designed, created by humans, by people, Abantu, for Abantu, to help us understand our world. Okay, it always makes sense. Now, in exponents, there's a whole lot of laws, okay? And they're kind of the rules of the game that we're going to be playing, okay? So the first one says this, but I don't want us to worry about the law first. I want us to look at something like this. If I get a cubed times a squared, right? Maybe someone can just tell me what does this actually mean if I write it out in full? If I write it out in full without the exponents, yeah, thank you. What is it going to be? What does a cubed mean? Someone already told us what x cubed means, so this should be easy.
What is a
So I want you to tell me if I write this without the exponent, if I just expand it, what is it? What does a cubed mean? A? Yeah. And that piece there, that there is a cubed. Okay. What does a squared mean? Times a? No, just 2. A times a is that piece there. How do I say? So Camilla, in this unit, there's 2 words for. There's only 1 word for blue and for green. Okay, and it's luhlaza. But then you say it's blue-green, like the grass, Jengo Chani, Norma, blue-green, like the sky, but now I can't remember. It's a baga. Okay. All right. So, guys, what answer now? How many A's have I got all together? 5. 5 A's multiplying together. How do I write that as a shortcut? A to the 5. Okay. Mind you, let's do another one. Okay. A to the 50 times A to the 3. Okay. Now, if I write this out, if I expand it, how many A's will there be? 50. And if I write these ones out and I expand it, how many will there be? How many are there altogether? 53. So the final answer is A to the 53. Okay. Does it make sense? It always makes sense. So what this rules here says is it says when we multiply numbers and the bases are the same. Okay. Perfect. Okay, we're going to add the exponents. Okay. Excellent. All right. Now, so guys, I want to just show you that there's something that can go wrong here. Okay. Because I want to ask you about this. What is, and I want someone to take the microphone if you don't mind, and to tell me what will this be? Two raised by 10, 2 to the power of 10. Hala. Has anybody got any other answers that they think it might be? Yes, over here. Yeah, it is 1024. That's if you expand it. Okay. Anybody got a different answer that they might think that is right? Anyone? No? Are we okay? Right, guys. A very common error. Something that lots of people make a mistake with. They do this. Icon. Okay. Okay, guys, this, but then people say to me, but Paul, 2 times 2 is 4. Yes, 2 times 2 is 4, but this is not 2. This is 2 to the power of 3. Okay, what does 4 to the 10 mean? What does it mean? If we go back to what does 4 to the 10 mean? A bit 4 times 4 times 4, 10 fours. Did we have 10 fours? No, we had 10 twos. Okay, so that's the first law of exponents. Okay, it makes sense. It always makes sense. But what is also important is that these bases must be the same. Okay, now the next thing we're going to do, because in maths, everything is connected to everything else.
Okay, everything's connected. So I want us to look at fractions now. Quickly look at fractions. If we've got 6/10, can someone give me an equivalent fraction to 6/10? Anyone, just pass the microphone to anyone. There, it's coming to you. There we go. It is a Mnezaneli, I think. With the last can you give me a fraction that is equivalent to 6/10, that has the same value as 6/10? Any fraction, and there's lots of answers here. There's actually millions of answers. So I want a fraction that is equivalent to 6/10. 3/5, okay? Hello, I think you got quite a lot of help from your friends, but that's cool. Guys, one of the things I want to encourage you is to get a study buddy. Get someone who is serious about their maths and work with that person, okay? Get someone who wants to improve. So what you've done here, you've divided the top by 2 and the bottom by 2. You could also multiply the top by 8 and the bottom by 8. These fractions are all the same, okay? What we cannot do is subtract and subtract. Look here, I've subtracted 1 and subtracted 1. Are these equal? No. This one is actually exactly a half. This one is a bit more than a half. Okay, so you can't do that. We can divide or multiply by a number. Now let's look with exponents. If we've got, and guys, I'm hoping you're writing some of this stuff down. I know this might be not supposed to write all of it down. If we've got a to the 7 divided by a cubed, what does that actually mean? Can someone expand it? What does the top mean? It means, let's just say it together. A. Have I got enough? I've got 7. And on the bottom, A. Now, what you're going to do, and your teachers might say this word, and I'm hoping they don't, because it's not all that good. A lot of teachers say cancel. Okay, let's not cancel, because when you cancel something, there's nothing left. We're not canceling, we are dividing by A and by A on the top and the bottom. So this fraction, what's this fraction if we write it, if we write it with exponents? This is a to the 6 over a squared. This fraction is exactly the same as that fraction. Now let's do that again. Let's divide by a and divide by a. And notice every time I divide by a, I'm putting a little 1 there, because when we divide by a, we're getting 1. And one more time. So what's left on the bottom? And if I cancel, there would be nothing left. Maybe there would be 0. I haven't canceled. There's 1 times 1 times 1. What's on the bottom? Just 1. What's on the top? It's a. It's not 3a, guys. It's not 4a either. It's a to the power 4. Allah. Okay. Now, is that okay? Now, what if I gave you this one? A to the 20 over a to the 30. No, sorry. Sorry, I don't want to do that. A to the 20 over a to the 16. Do I need to write all those a's out? No. How many are there on the top? How many are there on the bottom? If I divide 1, a by a by a, divide by a, how many will there be left and where will they be? There will be a to the 4 on the top. Okay. All right. So what this rule says is that if our bases are the same and we divide, we subtract the exponents. I just want to show you something again here. If I've got 5 to the 7 and I divide by 5 squared, what will the answer be? 5 to the power of 5. Good. We must not divide these 5s and get 1 to the power of 5. Are you equal yet? Okay. Right. Guys, exponents are all about having the same base. Okay, the same base. All right. Now, so that's law number 2. But as I say, don't learn them as laws, just understand what's happening here. The next one. A I'm going to do something like a cubed squared. All right. What does it mean if we square something? Yeah, let's have someone on the microphone. Yeah, anyone. What does it mean if I square something? Yeah, there we go. You've got a microphone in your hand. You might not have wanted it, but you have it. Times by 2, so like this. Times by itself. Yes. So you want a cubed times a cubed, like that. Yeah. You want brackets? Yeah, we don't need brackets. Guys, to square something means to multiply it by itself. There it is, times by itself. Are we okay? Does law 1 help us? We could just maybe just hand the microphone to someone and ask them for the final answer on this one. We've got a cubed times a cubed. Remember, we did law 1 earlier. A to the power of 6. Okay, now I want you to ask yourself, yeah, someone with a microphone, just tell me, are we going to get that 6 by adding these two numbers or by multiplying these two numbers? Say it into the microphone so you've got the microphone. No. So I'm not asking that. I'm saying this 6 that's over here, will it come from adding the 3 and the 2? Norma, will it come from multiplying the 3 and the 2? Multiply. Okay, thank you. So what this rule says is that when we've got a power and there's another power outside, we multiply the powers. Okay, so just write one more down and quickly, maybe you guys can just write these two down and just try and do them. You don't have to, just get the final answers and we'll get the microphone to you. A to the 5 to the 10, and then we'll also give you one with a red pen here. A to the, let's not go with A, let's go with C to the 6 to the 4. All right, anyone got an answer for me on that black one? A to the power of 15 or 15? 15, hala. Okay, and the red one, thank you. D to the power of 24. Did you use a calculator for the 6 times 4, or did you know it was 6 times 4 was 24? You knew, hala. Hey, now, please. Guys, your basic numbers, your multiplication, your tables, they're so important in maths. Okay, now the next one. Okay, we've got a product. Look here, we've got a product. So we've got something like C, D, and we're going to cube it. Okay, what if we write it out in full? What does it mean when we cube something? What does it mean to cube something? Now speak into the microphone, yeah. You multiply CD by? Yeah, so I'm wanting to write it out in full. I think you know what the answer is, but I'm wanting to, if I cube something, it means you multiply it by itself 3 times. That's exactly right. So we're going to get another one here and another one here. All right, we're going to get CD times CD times CD. Now, I'm hoping you guys know that you can multiply numbers in any order. What is 2 times 3? 6. What is 3 times 2? 6. So instead of writing C times D times C times D times C times D, I could write C times C times C times D times D times D. Okay, yes? Okay, what's the shortcut for writing C times C times C? C squared, C cubed, D cubed. Okay, which when I had a product, listen carefully now, when I had a product and I raised it and I cubed it, did the C get cubed or the D get cubed, or do they both get cubed? they both get cubed. And that's what this law is saying here. It's saying if we've got AB to the power of M, both of them must get the M. Okay, I want you all to just do this one. And I'm going to ask for someone to give me their answer. Good. Okay. Good. Allah. The 2 gets squared. 2 squared we know is 4. 2 times 2. And the D gets squared. 4D squared. Okay. Now, I want you to make sure you write this down. I'm going to write it in red because it's really important. If I've got something like D plus 2 all squared, this is different. Okay. Right? This is not a product. Okay. Anybody want to tell me what they think the answer to this is? And I guess I'm scared. Okay, because I think I'm going to get a wrong answer. I might be wrong, but I'm worried. Okay, don't be scared. Tell me what you think.
D squared plus 4.
Okay, so someone on my computer on the other side, I don't know if it's Northern Lisa, one of the schools who's online, also said D squared plus 4. Okay, and I'm also a bit sad. Okay, and can I tell you why? All right, but what I want to tell you is that if I had R1, Eleanor, just R1, for every time I saw that error, I would be a millionaire. I would have millions and millions of rands. I've been teaching for 30 years. You can see I've got all this hair and floor. Okay, all my white hair. If I had R1 every time I saw a learner do this, okay, and I've taught lots of learners, I would be a millionaire. Does anyone know what I would do if I was a millionaire? What do you think I might do? Okay? Buy a fancy car,
Buy
go on
a big
holiday,
house.
maybe
Buy
buy
a
a
big
new
house.
watch. I
A
call it. You
big
know what I would
house.
do? I would carry on teaching maths because I love teaching maths to you guys. Okay, right. This is wrong, guys. Can someone tell me why it's wrong? Because the rule doesn't say time. There's no time. Tell me what it should be. Yeah. Hello, no. Okay, guys, I'm not going to go straight to the answer like that very clever gentleman over there did. I'm going to write down, what does squaring mean? It means times by itself. Okay, so we are timesing D plus 2 by itself. Now, you guys know, and I'm hoping you know, that when you multiply brackets, everything in the first bracket must multiply by everything in the second bracket. So this D must multiply by this D, and we get D squared. This D must also multiply by this 2, and we get 2D. This 2 must multiply by this D, and we get another 2D. And lastly, this 2 must multiply by this 2, and we get a 4. All right, and the final answer is D squared plus 4D plus 4. Okay, so do not confuse this rule with when we've got a sum. All right, when we've got more than one term. Okay, here's the final answer. Some of you may have learned. Have you guys got a little word that you use when you multiply a bracket by bracket? FOIL. Yeah, some schools, some teachers use FOIL. The first one in each bracket, the outer ones, the inner ones, and the last ones. Called what? FOIL does not help us here. All we need to remember is everything in this bracket will multiply by everything in this bracket. Okay, so actually, and I'm going to do it quickly, we would get A times C Let's multiply the A by everything first. A times D, A times E, B times C, B times D, and B times E. Okay, all right. So that's law number 4 that we've looked at. Law number 5 says that if we've got a fraction and we cube it, which one will get cubed, the top or the bottom or both? Both. X cubed over y cubed. I want all of you to try. We're running. I know we're running a little out of space here. Okay, so yeah. All right. I'm going to ask you to actually go to the blank page on the other side there. Okay, and I want us just to look at this. So if you saw, we had like 5 laws. I want us just to look at this. What will happen if I've got x to the 7 divided by x to the 7? Which law tells me what to do when I'm dividing with the same basis? Law number 2. And what does it say? It says, okay, so it'll be x to the power of 0. Okay, x to the power of 0, guys. If we think about it, x to the 7 divided by x to the 7, and we cross out x's, we will be left with no x's, but we'll be left with 1s where everything was. So anything to the power of 0 is 1. Okay, I'm going to show you. I'm going to ask Ma'am Camilla just to give the microphone to someone. I want you just to tell me how old you are. This is an easy question. You can't get this one wrong. How old are you?
17.
16. Okay, have a look here. 16 to the power of 0. 1. Okay, all right. Give the microphone to the person next to you. Okay, I want you to tell me how many brothers and sisters you've got. How many people in your family? Children and parents. 3. 3 to the power of 0 equals 1. How old do you guys think I am? 50. That's very kind of you. Okay. Anybody else think I'm a different age? 60. It's 45. Here's my friend. I hope someone said 80.
90.
62. Okay. Guys, I'm 56. Okay. Quadra, 56 to the power of 0 is? Okay. All right. Can I just ask, has everybody in the room signed the registers, guys? Everybody signed the register. Okay, it's really, really important that you've signed a register because, yeah, it helps us when we're trying to approach businesses and people for funding. It helps that we've got the registers. Okay, right. So now I want to ask you this: what will law number 2 is the law that says? So I'm just going to write this down. Anything to the 0 equals 1. All right. What about this? What does law number 2 say the answer should be for this? That we've got the same basis. X to the negative 3. Okay. All right. Now, that's right. 8 minus 11, negative 3. The bases are the same. We're going to subtract. Okay. Now, let's have a look at what this actually means. What does x to the 8 mean? It means 8 x's. 1, 2, 3, 4, 5, 6, 7. I need one more. And on the bottom, how many x's have I got?
11 x's.
Now, if I divide, not cancel, if I divide by x on the top and on the bottom, where will there be spare x's? How many? 3. So x to the minus 3 is exactly the same as having 3 x's on the bottom. Okay, does it make sense? All right, now I'm going to ask you to just write this question down, and I want you all to try it, okay, because we're going to use all the laws that we've come across. I've just added one thing on the top, so just make sure you've got the whole question sort of before we start. Now, this looks quite scary because it's got quite a lot going on, but just remember the laws and let's see what we can do here. Maybe work out the numerator, the top first, and write down the bottom, and then see where we're going to go. Okay, let's see if we've got a volunteer. Just to tell me, what does the numerator, the top, what does the numerator come to if we multiply the thing? The only law you're going to need on the top is law number 1.
So first,
Scuso.
Sorry, sir. We can't hear you.
Hi, Paul. Please unmute yourself.
All right. I was actually trying to thank you. I was actually trying to mute someone there because I'm hearing you guys. If it's okay, I'm gonna mute all of you because I am hearing some of you answering questions, which is cool, but it's it's too much. Okay, thanks. Right. Okay. Now we've got x to the minus 6. My friend with the microphone, what is 8 minus minus 2? It's 10. It's 8 plus 2. All right. That is integers. That is grade 8. Okay. And we don't need to worry about that. Now, we don't like to write our answer with negative exponents. So what must I do now? Y over?
So it's 1 over x to the
What about the y? It's y to the 10. But is it on the top or is it on the bottom? It's on the top. It's got a positive exponent. The x to the minus 6 is the same as x to the 6 on the bottom. There's the final answer. Okay. All right. Now, guys, I want to show you, I'm going to show you a different way of doing this question. Providing we've got multiplication signs, I can move things from the top to the bottom as long as I change the sign of the exponents. So what I'm going to do is this, I'm going to write x squared. I'm going to write y cubed. I'm not going to write the g at all because there's a g on the top and a g on the bottom. These y to the minus 2's, I'm going to put them on the top and I'm going to make them y to the plus 2. Is everyone okay with what I've done? I've taken this and instead of having it on the bottom, I've put it on the top, but I've changed the minus to a plus.
Yes.
This x to the minus 4, I'm going to write it on the bottom. That x to the 4, there's x to the 4 on the bottom. This x to the minus 4, I'm going to write it on the bottom down here. X to the power of 4. Okay, so just to use a pen here, the highlighter, that has become that. Are we okay? All right. Now, let's simplify using law number 1. What do we do when we multiply and our bases are the same? We add the exponents. X squared, y to the 5. I've set this up somewhere. Okay, so there's a, I have missed, thank you very much. There was a y to the 5 here that I forgot to write down. Okay, I'm trying to show you that we're going to get the same answer, and I'm doing my best to stop that. What will my power on the y's be if I've got a y cubed, a y squared, and a y to the 5? 10. Good, because I'm going to add all of them. On the bottom, what will my power be on the x's? 8. Okay. Now, when I divide, what must I do to these powers? So there's two ways of thinking about this now. I can either go the sort of long way and say x to the minus 6, y to the 10. Or I can say, if I was to cross out x's on the top and the bottom, divide by x, where would the spare x's be? Would they be on the top or the bottom? How many? 6. Okay, and these two things, this over here and this over here, are exactly the same. Okay, does it make sense? It's all about rules, guys. There's an app on your phone called Photomath, okay, where you can take a photo and the app will just give you the answer. Okay, I don't think I can. I don't think I can share my phone screen, so I'm not sure how to do that. But yeah, The reason your phone can do that, the reason a computer can do that is because it's all about the rules that we've done. Right, I want you to go to page 4. Now, we're not going to do every question today, right? But I do want you to do question 1, question 2, question 3, and question 4. All right, and I'm going to give you a little bit of time. I'm happy for you to talk to the person next to you. That's the social activity. It's much more fun to do it with someone. Discuss your answer with the person next to you. We've got those 4 questions. I'm going to give you maybe 3 minutes, 4 minutes, okay, to just do those questions, and then we'll take some answers. If there are teachers in the room, maybe you want to walk around and see how the learners are doing, if they're needing any help. Maybe you can put anyone who's got a problem, you can maybe put your hands up and ask. All right, I'm looking maybe for an answer just to the first question. If you think you've got the first question right, maybe you could just put your hand up. Just the first question. Yeah, let's go somewhere in a different space here where we're getting some new. Yeah, those learners from Asitutuke. The learners in the blue shirt. Is that Asitutuke here? No. Where Matt just walked past now, what school is it? Because I'm just wondering, maybe if you move, so we're not blocking the road. Anyway, okay, let's have a go. All right, what did you get? 5/4. Well done. Okay, it's a half plus 3/4. Manje, Nancy King, we've got a problem. We've got fractions. I want to quickly remind you something about fractions. If I've got, because sometimes when we go back to earlier maths, it suddenly makes sense. If I've got Amarandi Amataku, and I've got $2, can I add them? No, I can't add them. They are different things. Okay. What could I do if I know the exchange rate? I could change these rands to dollars. Norma, I could change the dollars to rands. What else could I do? I could change them both to something else, maybe like euro, something else. Look at this. If I've got 3 centimeters and 20 millimeters, can I add those? No, they're different things. Okay, right. I could change these centimeters to millimeters. Can I add them now? Yes. How many millimeters? I've got 50 millimeters. Here I've got a half plus 3/4. These are different things. These are halves, these are quarters. Can I add them straight away? No. I need to make one of them. I've got choices. Singaketa. We can choose. I can make them both into what? Quarters. Or I could make them both into 40ths. Or I could make them both into 20ths. But I think the easiest thing, let's make them both into quarters. What can I do to get an equivalent fraction here? Times by 2/2. What's 2/2? It's 1. I'm not changing the value. So this half is exactly the same as 2 quarters. So now I've got 2 quarters and I've got 3 quarters. Can I add them now? Yes. And my final answer, 5 quarters. Okay. It makes sense. It always makes sense. All right. Who can tell me the answer for this next one? Yeah, so there we go. Thank you. No. Because when we've got a power and we put another power, we must multiply. How do we multiply fractions? We just multiply the tops and we multiply the bottoms. Okay. All right. This one over here may be a little tricky, but let's see. Anybody? Well done. It is 1/x. Okay. Now the reason, guys, this here, this is a half to the -2. No, it's not 1/x. Sorry. It's actually not 1/x. Sorry, it is 1/x. Sorry. Okay. So what we're going to do, we're going to multiply these two fractions together. This -2 that's here, is that -2 on the top or the bottom? It's on the top. What's on the bottom? 1. Okay. So there's some seats here, guys. Thank you. Yeah. It just helps. It's just easier for man to move. Yeah. There's 2 seats here. There's another seat here at the front. Yeah. It's just easier if we've got the alternate rows empty. So we actually don't really want learners sitting there where that guy's going to sit right now. Okay. Never mind. Okay. So, right. When I multiply here, what do I get when I multiply 1/2 by -2/1? X to the -1 or -2/2, which is -1. Now, I don't want a negative exponent. So what do I do? 1/x. Okay. All right. Number 4. I'm looking, maybe someone can give me their final answer and we'll see if it's right or wrong. La. Well done. All right. Okay. Guys, 24 divided by 6. 4. A to the 5 divided by A to the 4. Now we've got B to the -3 divided by B to the -2. We're going to subtract the exponents. We're going to get B to the -5. Hang on. No, sorry. It's B to the -3 minus -2. So it's B to the -3 plus 2. It's B to the -1. It's the B on the bottom. The other way of thinking about this, which is actually easier, guys, if I take these B to the -3s and I put them on the bottom, what do they become? They become B to the +3, and they're now gone from there. And now we can easily see why it's B to the 1 on the bottom. Do you see how, as long as we know the rules, we can change things, we can do things, we can try things. Okay. I'm going to ask us to try number 5. Now, the thing with a question like number 5, maybe it looks scary, okay, because there's quite a lot going on. But if we just do it one step at a time and we show our working, we can get lots of marks for this question. This question is either 4 marks or 5 marks. If you leave it out and you write nothing, what will you get? You'll get 0. Okay, so don't be frightened to try. Always try and just see what we're going to get. So mind you, we can choose. We can simplify these fractions first, or we can multiply them and then simplify them. We will get the same answer. Talk to the person next to you. Ask them, what have you got? Okay, guys, what I'm going to do is I'm going to use photo math. I'm going to take a photo of this question, right? This question that I'm asking you to do. I'm hoping you see on the screen that it's like you are. Right, here's the question. Okay, and so photo math says, so get the fact, right? So then you can check your math. Photo math says that the answer to this question is 6a squared b. Okay, now let's see if we can. Anybody want to tell me how to do this question? Now you know whether you've got it right or wrong. Okay, let's go.
Then A, I take one place, then add the exponents, which is 5, A to the power 5, then B, I take one place, and let's say negative 1 plus 2 plus 2.
Yeah.
I take one place, but firstly, so for the A gets it, this is raised to power 2, all in.
Yeah, so a squared cubed, what is that? Same as
It's
6, yeah. Okay.
as a
Have I made a mistake? That's right. A to the power 6. You're doing very well. What happens on the denominator now with when you multiply the a to the minus 3 and the a to the 6?
A to the power of if we take one place.
Yeah.
Take the exponent.
Well done. Okay. Right. Keep going.
To then A 5, then A is 5.
Yeah. What's 5 minus 3? Yeah. Okay. And that's, guys, well done. That's what photo math said. Well. Okay. Now, we're not going to do all of them because I want to get onto a different type of question. So, but I'm not in fact going to do this question, but I just want to remind us, how do we divide fractions? What do? We change it to a times and we turn this one over. Okay. All right. Let's just quickly look here, guys. What is a cubed over a squared going to be? What will it be? It will just be a. Is that a on the top or the bottom? On the top. Who can tell me how many b's will I have on the bottom in this question? And I'm wanting you to think about moving these ones down and changing them to a positive. How many b's will I have on the bottom? 3. Well done. I have 3 b's on the bottom. I'm not going to do this whole question. This is going to be b to the minus 1. Don't try and do like 2 things at once here, because at the moment, all I'm doing is I'm just turning this one over, a cubed b. All right. I want us to leave that question, and I know maybe you'll be a bit frustrated that I'm leaving it, and I'm also leaving number 8 because I want us to go to question number 2, Pendula Ikasi, question number 2 on page 5. All right, now I'm going to play you a song. Okay. I like music. Do you guys like music? Yeah. All right, so I'm going to quickly play you a song. Do you like it or not? I don't like it. But guys, what she's saying all about that, about that. Okay. She's actually talking about base, like BASS. But if we go back and we look at our exponent laws, okay? If we go back here to the laws, oh, I've lost them now, here they are. All right. The laws that we were doing. What did we say? We said the bases are the same all the time. And so our laws are only going to apply when we've got the same basis. We can't start adding exponents here because we don't have the same basis. So we want to try and take a number like 12 and write it. And I'm going to ask you guys to try and do this. We want you to try and change all of these numbers so that they are products of prime numbers. And again, we did this in grade 8. Okay. All right. So let's just remind ourselves what the first few prime numbers are. They are 2, 3, 5, and 7. I don't think we're going to need anything bigger than that for here. All right. Who can tell me what is 12? All right. Maybe just put your hand up. What is 12 if we break it down into prime factors? Yeah, just you can, the man over there from Injalova, you put your hand up now. He's now looking down. Okay, it's changed his mind. 12. Yeah. Do you know the answer? 12 is, if you can just shout it out. Yeah, say it louder. Hello, no. Guys, 12 is 2 squared times 3. Okay. Now, you might not have got there so directly. Maybe you know that 12 is 6 times 2. 6 is a problem because it's not a prime number. 2 is a prime number. What is 6? 6 is 2 times 3. So 12 is 2 times 3 times 2. But that gentleman over there has already collected the two 2's together and said that's 2 squared times 3. Allah. What about 9? 3 squared. All right. 4, I think, is easy. 2 squared. I'm going to ask someone to take the microphone for 18 because that's a little bit trickier. 18. We go just in front. Two times 3 squared. Okay. Now, I'm going to ask you guys some questions here. When you've got a product, look at this product. When you've got a product and you've got a power, which one gets the power? No, both of them get the power. Okay. I'm going to ask you another question. When you've got a number with a power on already and you put another power on, do you add or do you multiply the powers? You multiply the powers. I'm going to go and remind you of the rule. Guys, here's the rule. There's the rule that says that they both get the power. And there's the rule that says that we multiply the powers. Okay. I want you to try and finish that question. Okay. Once again, I'm going to take a photo of it with photo math. Seems so frozen. Okay, so my photo maths is not happy. All right, let's see what we've got here. Anybody want to? Yeah, we've got a volunteer there. Yeah, thanks, Camilla. So your vitality steps are going to be up for the day. Yeah.
Two times square times 2 of 2x minus 1 4x minus 3.
Okay, you did say over there, you actually said 2 squared times that. It's actually 2 squared to the power of, but that's, you're absolutely right. Okay, carry on. Well done. What power is on this 3? To 1, yeah. And so when I multiply that, it just becomes that. Okay, and then?
I said 3 to the power of 2 into 3. 2x minus plus 4.
Well done. Okay. Guys, do you see that although this is a big problem, it's made up of little bits, little steps. If you want to climb a mountain, you don't climb it in one go, you climb it in one step at a time. Okay, carry on the denominator. What have we got? Yes.
To the power of 2x
Yes.
or 4x.
Well done. Okay, carry on. Yes. Yes.
Take 1 please, take 4x minus 2 minus 2 minus 2x minus 2x.
All right, is everyone okay with what we're doing here? Because we're dividing, we are subtracting these exponents that are on the bottom. Well done. Okay. Right, and carry on. Times 5.
The power of 2x minus 1
Yeah.
minus 2x plus 4.
Plus.
No, it's minus. Oh,
Yeah. Plus 2x
2x
plus 4.
minus 4x.
Okay. You're doing quite a lot in one go there, but that's absolutely fine. Right? Carry on.
Okay, which is the power of linkage.
Right? Well done, because all the x is subtracted.
Yes.
3 to the power of
Positive 3. Negative 1 plus 4 is 3. And again, the x is subtract. Now, we close, but we don't want negative exponents.
3 all over 3 to the power.
Well done. Okay. And we can, if we want to, because our numbers are not very big, we can. Yeah. I'm sure, and I'm going to have one last try. I'm sure if I try with photo maths, we're going to get that answer, but I don't know if it's going to. My phone's a bit sad with me at the moment. Yeah, what happens is the phone starts lagging. I don't know why this is not working. Sorry. Okay. Right. I promise you the answer is 27/4. All right, guys, we're not going to do lots of these either, but I do want you to try number 4. All of you try number 4.
One question. This is not what I was saying. Pretty good as an audience and what's coming to see. Yeah. And so, just not, yeah.
Oh, okay, I've got to watch now. Can I try to do it myself? Can I try to do it? Maybe I haven't got around. Oh, okay. You could just shout if I'm getting it wrong.
Women don't need to be embarrassed about blush, but did you know 79% of women will experience it at least once in their life, whether caused by diet, stress, or antibiotics? Can this be one proceed for treatment that cause and cure by treating the cause and relieving the itch? For convenient, effective relief from thrush at 10 times the strength. Trust Connected One Proceed. Available without prescription at your pharmacy. Advil, the latest product news. And it's so
Down. So it is not for steps here, but all small steps that are the same rule that we've been using all along. Okay. So just going to keep calm, keep practicing. When you start speaking, yeah, I've read sometimes it.
Oh,
Can come to the beginning. I'm not looking at. But the two elements. That two into the bracket.
does it help you or does it make it more confusing?
No.
Yeah. Do you want someone to do the answer? Do you want someone to do the answer or would you?
It's started from, I want to started from where, okay, because I'm pretty very long. Tell them what you're at on the new right now. Minus 4x plus 2. plus 2x minus 4 minus 4x plus 2. Right, and then what? So 2 minus 5 minus 4x plus 2 minus 4x. Right.
So we've got 4x
So
minus,
the 4x is against yeah, 2x minus 4. Okay. Right. So we can even say 2 to the power of 4. Normally we can say 2x minus 4, but we must say 2 times 4, which is just over the top, but that's fine. All right. Right. 3 to the power of minus 1. Okay. Then, then, and then, all going to go to 0. Right? Yeah. So it hasn't got the green pen, so.
sorry.
3 to the 0 x negative.
Oh, can I just take that out?
Minus 1. Okay. The final, give a positive split. Yeah. 2 to the power of 4 over 3 to the power of 1. You can believe you could scroll them up, yeah. The power of 4 is also the same as 16, like that. All right. Great, well done. I guess this is the last one. I'll just again, just be learning to write on this thing for the first time, and it takes a little bit of getting used to, because when I write on here, have a look at this thing. I can't see what I'm writing, so we've got to watch the screen and try and see what's happening. Okay, now we're going to look at another type. Okay, and I'm going to write up another one here for you that I want you guys to write down. I want you to write this down. I want you to write that down first, and I'm going to explain why. Right. So we're at the top of page 6, guys. So can I, and I want to know the answer to this question. Can I cancel these 4s? No ways. I'm so pleased that everyone said no. I equally into. Okay, because remember, all we are allowed to do is we're allowed to divide or multiply. To get an equivalent fraction, we can divide or multiply. Now, that's the key here, because we've got 2 terms on the top and we've got 2 terms on the bottom. What can I do? What should I do before I simplify? Factorize. What is the common factor on the top? 2, and what goes inside? Okay, and how does the bottom factorize? Something plus what? It's a difference of 2 squares. So it's x and x plus 2 minus 2. Can I now divide, not cancel, divide by x plus 2 and by x plus 2? Yes, because I've got 1 term on the top and 1 term on the bottom. There's a multiplication sign there and a multiplication sign there. Now, what is my answer now? 2 over x minus 2. Can I cancel these 2's? I can't. All right, that's the final answer. Now,
we've done that before. We've done factorizing before. Now we need to combine that thinking with some exponents. So I want us to do this one first. 3 to the n plus 1 minus 3 to the n over 2 lots of 3 to the n. I want you to try and factorize. So I want you to write that one down. I know we might be a bit short of space, but try and write that one down and try and then factorize. We cannot, i.e. Corleator, we cannot cross these out because of this minus sign. When someone's ready, you can put your hand up, and ma'am will come to you with a microphone to tell us how to do this. It's all about our laws of exponents. All right, I'm looking for an answer. Yes. Yeah. 3 to the n. Okay. Okay. I want you to stop there, and you're 100% correct. Okay. I want to just make sure that we understand, guys, when we multiply 3 to the n by 3 to the 1 with the same base, what will we do? We will add the exponents. Okay. Right? And here, 3 to the n times 1, okay, will give us 3 to the n. Put a power of 3 here, and if so, what power should I have on this 3? Hello. And what is 3 to the 0 anyway? It's 1. Because remember, if we multiply and our bases are the same, we're going to add the exponents and I'm going to get n plus 0, I get n. Does it make sense? What's the answer to does it make sense? It always makes sense. Okay. Is it valid? See? Okay. In Java. Okay. All right. Carry on. Yeah. Okay. What can we divide out here? Yeah. So I was also divide this one. Huh? Yeah. So we get 2 divided by 2, which is okay. Well done. Very nice. All right. I want you guys to try number 1. We are going to take a tea break fairly soon. So I know we've been going for quite a long time and you're getting tired. I understand that. But we're going to try number 1. Try number 1 and try number 4. Okay. Try number 1 and try number 4. Right. We will look for a volunteer. And is it interloper? No. Is it interloper? Yeah. Let's go there with the man without the jersey. Okay. There we go. All right. Okay, talk into the microphone. Nice and clear.
Already. Mr. Next one, then minus 4 times 2, that's what it's 2.
Well done. Okay, that's exactly right. Guys, that 4 needs to be there because that 4 is just a normal 4 that's going to multiply, right? When we multiply the 2 to the m by the 4, that's just going to be there. That 4 is going to be there. When we multiply the 2 to the m by the 2 to the 2, we're going to add the powers and we're going to get 2 to the m plus 2. Okay, nice. Carry on.
We're gonna do that 2 into them.
Yeah.
Then open bracket 1 minus 2 is to 1.
Okay.
Then 2 is to m is gonna divide 2 is to m.
Well done. Okay.
And we're going to 3 minus 8.
It's not going to be minus 8, I don't think. Yeah. And guys, just be careful here. What we can't do is multiply the 4 by the 2 and then square it, because the 4 is not being squared, just the 2. So we actually need to work out what is 2 squared. It's 4 times 4, 16. And on the denominator, what have we got?
2.
1 minus 2.
1.
Negative 1. Okay. On the numerator, what have we got? Negative 13. On the denominator, we got negative 1. In grade 8, we learned that when we divide a negative by a negative, we get a positive. Okay, well done. Allah. Right, now number 4 is a little bit tricky because we've got different bases again here as well. So you might want to prime factorize that base first. It's all about that base, about that base, about that base, all about that. Okay, you see why I'm a maths teacher, not a singer, guys. Yeah. Right, we're looking for a volunteer. Got one there. Yeah. Right.
First, we are going to check the 6.
Yeah.
2 times.
Okay.
Then 2 5 times 2
Yeah.
times 3 to the power 30. Then it's 3 and
Like that or not? Now you want to split this? Okay, tell me how I'm going to split it. Okay, good. Is everyone okay with that, guys? Something that I didn't really reinforce is that the rules work both ways. So we saw the rules saying when you multiply, you add your exponents. So 3 to the n times 3 to the 1 becomes 3 to the n plus 1. But what this learner has said is we can split that to go 3 to the n times 3 to the 1. Okay, great. Nice. That's 3, okay. Yeah, because that 3, this 3 that I'm writing now is actually this 3 here. Okay, and then on the denominator. Okay, and what can I do now? I can divide the whole lot. Okay. That and that. Final answer. 3 to the power of n. Okay, right. Guys, we're going to stop there for tea at thirds. Okay, we're not going to spend very long on this because it's not as important as some of the other stuff that I want us to get into. But we are going to just take a look. The first thing is this rule over here. All right, and what it says is that if we've got a number, right, with a power on like that, then we can write that as a root. Okay, and I want you to watch which number stays outside and which number goes inside. The 5 is the base, it's inside. What goes here? The 3 goes here and the 2 goes here. So let's just check what that's saying to us. On a calculator, if we find 5, so my calculator is just getting jammed up there. There we go. If we take 5 to the power of 2 over 3, so 5 to the power fraction 2 over 3, I get 2,924, right? If I find the cube root of 5 squared, I get exactly the same. So it's the same thing, okay? Right, a really important one, and guys, this is going to be important later in grade 12. You're going to do something called calculus, which is really, really cool. But a really important one is to be able to take something like this and write it with a power. Now, let's just think about what power we're going to have. What power is on this 9 here? 1. And what sort of root is this? 2. It's a square root. Okay. So square rooting a number is actually the same as raising it to the power of a half. Okay. Now, we have a whole lot of laws here, which they're not, to be honest, only really number 1 and number 4 are that important. So I'm just going to talk about number 1. And what it says is that if we've got a product, listen to this, a product of some roots. I want you to write that because there's the words. The product of roots is equal to the root of the product. So, for example, if we've got, right, if we've got root 3 times root 6, that will be the same as what? Root 18, 3 times 6. Okay. Also, if we've got something like root 25 times 2, I can pull those apart, all right? I can pull those apart and I can put roots over each of them separately like that. Okay, what is root 25? 5. So in fact, if we type into our calculator, because 25 times 2 is 50, if we type into our calculator root 50, our calculator does all of that for us. It actually says, actually, 50 can be written as 25 times 2, And then I can square root them separately, and there it gives us the answer. Okay, so yeah, that's we're gonna look at a kind of an example of this just now, just to show you why this makes sense. All right, if we've got the nth root of a, and we multiply by the nth root of b. Okay, how can I write this? The nth root of a, how can I write that with an exponent? A to the what? Well done. It's going to be 1 over n. And b, and the nth root of b will be b to the 1 over n. Now, I want you to think back to rule number 3, and I'm going to quickly shoot up to rule number 3. Because what rule number 3 says, if you go right back, law number 3, what it says is that if you've got a product with a power, which one gets the power? Both. But it also goes this way. If you've got two numbers with the same power, you can put them in a bracket and put the power outside. So that's exactly what I'm going to do now. I'm going to take this A and this B, and I'm going to put them like that. All right. And now let's take this back into surd form. What will go where? The AB will go inside, and where will the N go? Outside. All right. So the rule is a complete follow on, or completely follows from our exponent rules. Okay, we're not going to do lots of these. I'm going to just look at number 1. Okay. What we want to do, we want to try and break 8 into a product, ideally where we know where we've got a perfect square. Okay, so 8 times 1 is not a good idea, because then we're just going to get root 8 times root 1. How can I break 8 up? 4 times 2. How can I break 32 up? And I want you to try and get a perfect square. 16 times 2, okay? You might have said 4 times 8. 4 times 8 is not wrong, but then the 8 will break up more, okay? What about 50? So there's a 3 outside, 25 times 2. Okay. Right, now. What I'm going to do now is I'm going to split these like this. Okay. What is root 4? 2 times this 2. 4 root 2. What's root 16? 4 times 4. 16 root 2. And 25. 5 times 3. 15 root 2. These are like terms. All of these terms have got the same type of thing. Remember earlier I was talking about rands and dollars, and I was also talking about centimeters and millimeters, and I was also talking about halves and quarters, and I said I couldn't add them because they're different things. These are all the same type of thing. I've got 4 of them. I minus 16 and I add 15. All right, what's the final answer? 3. All right, and remember, just as a, because we can add them in any order. So maybe it's easier to say 4 plus 15 is 19 minus 16, 3 root 2. Or minus 16 plus 15 is minus 1 plus 4 is 3 root 2. Doesn't matter what order we go. Okay. All right. Guys, I'm not going to do lots of these, but I do want us to do this one, number 3. All right. And remember, do you remember the question earlier, the one earlier where I said I would have, if I had 1 rand for every time I saw the error? Do you remember that? Yeah. This is the same thing. The same thing. Do not just square the 2 and square the root 3. See if you can work out the final answer to this one. At the mic, yeah, great. Okay, guys, so when someone's got an answer that they're happy to share with us, maybe they can just call ma'am and she'll come and check it out with you.
Sakuzwa bhuti, asisakuzwa bhuti.
Yena khuluma. Hey, uyaqina wena silende. Oh, nanti. Nanti ngithike silende. Badeli.
Okay, we got. Oh, we got.
We can't hear you, sir.
You can't hear me. Thanks. Well, I wasn't actually talking. Can you hear me now?
Yes.
Okay, great. I'm just trying to mute. I'm trying to mute others because otherwise I'm hearing you here. Yeah, I think everyone else is muted now. Okay. Right. Anyone want to tell us about this one? Great. Thank you. Okay, nice and loud into the microphone. So I've written the two brackets out. Yeah. Okay, so I remember √3 times √3. What the square root of 3 means is what number, when we multiply it by itself, will give us 3. And here we're doing exactly that. We are multiplying it by itself. So this will just be 3. Okay. Okay. Yeah. So guys, remember I said I don't like the word cancel. For me, this I'm much happier with the word cancel here, because these things are exactly the same size, the opposite sign, they are cancelling each other out. Okay. I don't really like cancel when we divide it. Okay. Yes. And now your final answer. 14. Well done. Okay. Excellent. Okay, guys, as I said, I don't want to spend too long on this stuff. The one thing I do want to show you, though, is that we do not like, and I said already to you today, everything's connected to everything else. A little bit later, probably one of the last things we're going to look at today is the nature of the roots. But this number over here is what we call an irrational number. Is an irrational number. It never ends and it never repeats. Right? We do not like irrational numbers on the bottom of a fraction. Okay, so there's a little trick that we need to learn, how to make the denominator into a rational number. Okay, can anyone tell me what can I do? And remember, I can't change the value of this number. I want an equivalent number, but I want it to have a rational denominator, a nice number that either ends or repeats. Okay. Divide or times. Yeah, absolutely. Hello, well done. What are we going to do? We're going to multiply by root 5 over root 5. And what I think I heard you say is that that's actually 1. Okay. So we're not changing the value. Right. Now, what does this become? It becomes 3 root 5 over 5. You might say, Paul, is it actually, could I write it as root 5 times 5? Yes. What's 5 times 5? It's 25. What's the square root of 25? It's 5. Okay. What I've done here is not necessary at all, but I'm just showing you that the rule, remember the rule says that the product of roots is the root of the product. Okay. I know we wouldn't show that step, but I'm just showing it to you because it's not wrong. Okay. Once again, your calculator does this for you. If you type into your calculator 3 over the square root of 5, it gives you that form. So your calculator has been programmed to do that for you. When I was at school, if I typed 3 over root 5 into my calculator, it would tell me that the answer is 1,3416. My calculator in those days couldn't do this. It just worked with the decimal numbers. So we needed to know how to do this. You still need to know how to do this because you need to show your working. Okay. Now we've got a bigger problem because we've got a binomial. We've got 2 terms. If we multiply by root 5 over root 5, that times that will give us a rational number. Am I right? But this times this will still give us an irrational number. You can tell us what we still multiply by here, so that, and remember, I've got to multiply the top and the bottom by the same, so that I get rid of the irrational number. And Camilla is going to be very fit at the end of the day, either very fit or very tired. Is it all? Just bring it here, Camilla. I suspect it's the battery issue.
I think.
Right, sorry, guys. Very well done. Square root 5 minus 2, square root 5 minus 2. Okay, now the big thing that happens here, this is almost like a difference of two squares factorizing, okay? When we multiply this out on the denominator, let's have a look. We're going to get root 5 times root 5, which is 5. We're going to get negative 2 root 5, and we're going to get positive 2 root 5. Halala. And the reason I'm saying halala is because our irrational numbers are going to cancel out. And what are we also going to get? 4 minus 4. On the top, what are we going to get? 3. Remember, and ma'am earlier was doing something like this. She was doing this, which I think is helpful. She's saying that that 3's got to multiply by both those things. Root 5 minus 6. Okay. So on the bottom, we actually end up with 5 minus 4. So we get 1. So we get 3 root 5 minus 6. And again, if I put the original thing into my calculator, the calculator actually does do it for us. Okay. But we need to be able to show our working. 3 over the square root of 5 plus 2. And there it is. Okay, notice. Are you okay that that's the same thing? Yes, the terms have just been swapped around. But the minus sign, because remember the sign that matters with the 6 is that sign there. That sign has gone with the 6. Okay. And this 3 root 5 is actually a positive. And it's kept its sign as well. Okay, and that's also something that I'm hoping you're comfortable with from grade 8. Is the number in front of the sign in front is the sign that applies to that number. Okay, so do you see why we had to change the sign to get the cancelling? All right, I'm not going to do this one, but if I asked you to rationalize the denominator of this, 2 over 7 minus the square root of 3, what would I multiply the top and the bottom by? Well done. 7 plus the square root of 3. I'm not going to finish that off. I just want us to make sure that we've kind of got that. Okay. Right. Now, then most of the rest of today, we're going to be talking about solving equations. Okay. And I want to quickly talk to you about the process of solving equations. And I want to share 2 ideas with you. All right. The first one is the idea, all right, of a scale, a balance, right? At Michael House, we're very lucky when we teach equations because the Michael House badge, I'm going to show it to you. This is what a Michael House badge looks like. Sorry. Here's a Michael House badge. Okay. On the Michael House badge is a set of scales. And those scales are balanced. They are equal. All right. Equal in balance. Okay. When you solve equations, I want you to think about a balance. The thing being equal on each side. That's the first thing. The second thing, I want you to think about undoing. Right? So I'm going to show you something. Okay, guys. So I tell you what's happening now, and it happened last week as well, is that the Wi-Fi is now struggling to catch up. So if you look what's happening, I'm not moving the pen. The pen's still moving. It's kind of all right. It's very irritating. I wonder if you've got a phone on you, please just turn your Wi-Fi off. Okay, because I think what's causing it is your guys' phones trying to connect. So just, if you don't mind, just turning your Wi-Fi off, and then you can turn it back on when we go outside. Okay, all right. So that's the first thing. The second thing is if I had something like this, and I'm doing a really simple one. Who can tell me in words what is happening to X? In words, I want you to use English, language, okay? Who can tell me what is happening to X? When in that, over here, on the left-hand side, what is happening to X? What does this 2x mean and what does the plus 3 mean? What is happening to X? Someone, come, this is not difficult. Yeah, over here. Yeah, there you go.
X and coefficient of 2.
Yeah, what does that coefficient of 2 mean? It means it's being times by 2. And then what's happening? Added by 3. Now let's just listen to this, guys. And I hope the people online can still hear me because I'm just going to walk on the stage here, just show you. When you get dressed, okay, and I'm just going to talk about 3 things. And these I'm going to quick and is it talking? The first thing I put on, then which the shoe, then okay. Guys, listen carefully. What's happening to X here? We times it by 2, and then we are adding 3. Then add 3. When you do that, I will undo in the opposite way. Times by 2, then add 3. Now, 3 divide by 2. That is a central step in solving equations. So what I'm going to do here is I'm going to minus 3. Now, today I'm going to ask you lots of times, from which side must I minus 3? From both sides, guys. This is the scale, it's balanced. I can't minus 3 from here, all right, without destroying the balance. If I minus 3, I must minus 3. You see I've minus 3 from both sides. It is still balanced. Now, what must I do? Okay, and guys, can I just talk about some language here and some teaching ideas here? Maybe the teachers can listen particularly carefully. A lot of teachers will say, take the 3 to the other side and change the sign. Okay, I'm tired. All right, I don't like that. I'll tell you why. Listen carefully, because over here, on the next line, I'm going to take the 2 to the other side, and I'm not going to change the sign. So here we're taking something to the other side and we're changing the sign. Here we're taking something to the other side and we're not changing the sign. The other thing that a lot of teachers teach, they talk about the transpose. Okay, and I'm hearing the learners say transpose. Okay, and again, what we're saying is we're saying it's transpose, put it on the other side and change the sign. I would far rather your language is let's subtract 3 from both sides. What's happening to the X here? It's being multiplied by 2. That chap over there told us just now. How do we undo multiplying by 2? Divide by 2 on which side? Both sides. Final answer, X equals 4. All right. Now, I'm going to show you one last thing. You guys know BODMAS, eh? BODMAS is our kind of order of our order of operations. But actually, it's now we should call it eBODMAS. Okay, because the E stands for exponent. Right. When I've got, who can tell me what number here? What is this number that I've written in red here? What's the final answer for that number? How much? 18. I'm hearing 18. Does anyone think it's 36? It's not 36. I've got to do the exponent first and then multiply by 2. All right. Now, let's have a look. What should I do here to make this just a little bit better? Divide by 2 on which side? You guys are quick learners. On both sides. Does everyone see what I've done? I've divided by 2 on both sides. Is this better or worse than it was? It's better. Now, guys, everything's connected to everything else in maths. Do you remember earlier we said that if we put a power out here, what will happen? Will it multiply or divide with this power? It will multiply. Okay? So, if I put a power out there, I've got to put the same power here. All right? Now, what I want to ask you is what power, and everything's coming together here because we've got some fractions and we've got all sorts going on here. What power can I put here so that I get a 1 there? Hello.
3 over 2.
Yeah. 2. I'm hearing some online learners giving the answer as well. It's great. All right. 3 over 2, because 3 over 2 is the power that will multiply with 2 over 3 to give 1. Okay. Notice when I multiply these fractions, I actually get 6 over 6, which is 1. Normally, I can divide the 2s and divide the 3s to get 1 over 1. Chord 1. I cannot raise the left-hand side to the power 3 over 2. What has happened? I've broken the balance, not balance. To fix it, I must also raise 16 to the 3 over 2. Okay. And now you can do this on a calculator. I'm going to show you that maybe we can even do it without a calculator. Can anyone tell me, can I write 16 as something squared? And the reason I'm wanting something squared is it will simplify. 16 is actually 4 squared. Okay. And now these will divide, not cancel, divide. And so I get a final answer of 4 cubed. Does anyone know what 4 cubed is? Well done, it's 64. All right, I want you to try number 4 next. I'm going to ask you to give your answer to 2 decimal places, because I don't think this is going to work out very nicely. I might be wrong, but I don't think so. Right, I'm looking for a volunteer when someone's got an answer for us. 2 decimal places, but I want you to tell us how you did it. I don't just want the answer, otherwise maybe you're using photo math. And I'm going to walk across the stage and I'm going to take the thing raised to the power of 5 over 10, then multiply by 3, then add 2. Okay, I want you to think about undoing that stuff. When we undo it, it's like me undressing. The last thing that went on is the first thing that must come off. Okay, we've got an answer here. I think at the end of the day, you must come and get from me a SIMI sticker. Okay, because you've answered so many questions for us. Okay, carry on. -2 from both sides. Just talk nice and loudly into the microphone, please. 88, great. We have subtracted 2 from both sides. Divide by 3 on both sides. Okay, I'm going to leave it like that. Okay, because I don't really need to worry about it for now. Okay, carry on. Okay, so what you're saying to me, you're going to take this left-hand side and you're going to raise it to the power 7/5. Okay. You're also going to raise to the 7/5. Guys, remember, you cannot do something to one side without doing it to the other side. Otherwise, that's in Kinga. Our scale is not balanced. Okay, what do we get here? 1 x to the power 1. Yes, yeah. 100. Okay, I'm going to just quickly check that on my calculator. I just want to see that you've done the rounding correctly. I think you probably have. Guys, so I'm going to use brackets. You guys are so lucky with the calculators you've got now because they actually, they look exactly as we typing the stuff as we write it. 7/5. 113, did you say 30? Okay, so if it's to 2 decimal places, we want to look at the third decimal place. If it's 5 or bigger, then this one must go up by 1. I'm wondering if maybe you rounded off your 88/3. And that's why your answer isn't as accurate as it should be. Okay, it's not a problem. But remember in maths, we're only going to round right at the very end. I want to teach you something here. I'm going to teach you guys a little trick on your calculator that maybe you don't know. All right. If you decided to work out 88/3. Now, the problem with 88/3 as a number, all right, it's actually 29,33333 forever, not 100 threes, not a million threes, not a billion threes, forever. Okay. Now, the problem is you can't write that number down accurately because you would have to write forever. Code your calculator can store numbers. This button over here, look at this button. On the top, it says STO for store. On the bottom, it says RCL for recall. So I'm going to go Shift Store. When you do that, the next thing your calculator wants is one of these red letters, A, B, C, D, E, F, X, Y, M. I'm going to go with A. All right. Even now, if I press all clear, even if I turn the calculator off, when I go recall A, I get that exact number back. So if you did that, okay, what you could now do is you could say recall A and then raise that to the power of 7/5. And you get the exact right answer. Okay, so you can store answers on your calculator. All right, even your friend's cell phone number. Okay, here's my cell phone number. 0.82. I'm not going to put in the 0. I'm just going to put 82. 824923769. There's my cell phone number. Okay, I can go Shift Store and I can say let's put that in D. All right, that number is in D now. It will be in D even if I turn the calculator off. When I get home, I want my friend's cell phone number. Recall D. Okay. All right. Okay. Right, guys. So now the next type of equation that we've got to do here is what's called exponential equations. What do you think x is equal to over here? It must be equal to 2, all right? And the reason it must be equal to 2, this is tied in actually to functions and stuff that we're going to do a bit later. The pen's now going walkabout again. All right. Okay. But the graph. Okay. So what we want to do This equation is called an exponential equation. Sorry, this pen is now trying to catch up. Guys, please, if you've got Wi-Fi on your phones, please just turn it off, because you can see what's happening here. I'm not writing anything, and the pen's like trying to catch up now. It's caught up. Okay. All right. This is called an exponential equation. And the reason it's an exponential equation is that the x is in the exponent. The variable is in the exponent. And what we want the same base on each side. But also, we only want one factor on each side. And I'm going to explain that just now. And we're going to use our exponent rules. Okay. All right. So I'm going to ask you to try number 1. I'm also going to ask you to try number 2. And then I'm also going to ask you to try number 3. Okay, number 1, 2, and 3. And I know I've added number 3 in. I know there's already a number 3. Okay. And I'm looking for volunteers, but I want the same base on each side. Okay. So number 1, you've got an answer for me. Let's go. No, tell me what's been about. So I'm gonna tell me what
The answer. You want the answer?
Read to the
Hello.
top, speak.
Let's say Bulal.
Sorry. So guys, the people who are online, and I'm really sorry, because I know I can hear someone trying to answer. All right. Unfortunately, I've got like 250 people in the room here, so I can't take answers from outside the room. Okay, and I see your hands up. Okay. Is this Tolani? I tell you what, Tolani, talk to me. Let me take your answer, but I'm not going to be able to take notes. Okay. Tell me what to write. Tolani, sorry, I'm going to come back to you for question number 2. You look at question number 2, which is a bit harder. Tolani, you tell me what to write.
Okay. It's x equals to 4.
X equals to 4. Okay, can you just tell me how you got that?
Oh, okay. I equated able. I reduced 27. It was 3 to the power of 3, and I equated able. Equated the bases, and transposed 1, which was 3 plus 1,
Yeah.
and I divide. Yes. And I divided by 2 both sides, and it was x equals to 4. You hear me? It's all good. Yabona Jen. Let's take care.
All right. If we equate the yes, please, if you've got Wi-Fi on your phones, just turn it off. I don't know if it's a Wi-Fi thing. I don't think it's actually a Wi-Fi thing. I don't know what it is. I have asked. Yeah. Kimberly, you can be glad you're not trying the pen at this stage. All right. Okay, guys, it's 1 minus 2x equals 3. All right, now I'm going to subtract 1 from both sides. What will I get? 2 minus 2x equals 2. Now, what must I do? I must divide both sides by negative 2. What is positive divided by negative? Negative 1. Okay. All right. Okay, Kalani, I think you started off right. I think you made a careless mistake.
Problem, yeah, a mistake. I did a mistake.
I go your ranking. Yeah? Okay. I'm going to mute you though, because I've got lots of people in the room here. Okay.
All right.
Sorry, sir, we can't hear you.
We can hear you, sir.
Sorry, sir, we can't hear you.
To myself. Okay. Goodness gracious. Sorry, can you hear me now? I'm sure you can hear me now.
Yes.
Okay. Yeah, sorry, man. Thank you for telling me. Yeah, okay. X equals 1. Well done. Okay. Allah. All right. Okay, guys, we're going to now move. We're going to leave those questions. All right. And we're going to just get onto some quadratic equations and some things. Okay. I don't want us to do all of them, but I want us to look at number A, and then I want you to look at D. All right. Sorry, guys. D. There's an error on D. This should be. No. There's not an error on D. It's fine. Do A and D. All right. But I want you to look at D carefully. All right. I'm going to write something here which you can think about. Yeah. This thing's jamming again. Okay, these are quadratic equations. Let's see. Okay, I'm looking for an answer for A. Yeah, here we go. There's a letter from, and I should know all your uniforms, guys. Okay, sorry. This letter, just tell me what school you're from. Jambula, sorry, man. I should know. I've been to your school many times and I know what your uniform is. I'm just getting confused. There are 9 different schools in the room. Yeah, okay. Tell me what to do here.
It's A.
Yeah. Okay. Okay. So you use the quadratic formula. Can you tell me your final 2 answers? Did you get them? Not yet. Okay. Okay. So sometimes the quadratic formula is not the best way to go. Okay, because this can factorize. Okay, and I want to give you guys a quick lesson on factorizing. Everyone agrees that there must be an X, there must be an X. Okay, now I want you to ask yourself this question. I'm going to start at the back and I'm going to look at this side. If I want a negative product, must I have a plus and a minus, or 2 minuses or 2 pluses? I must have a plus and a minus. So straight away I can put those numbers in. Now, listen to what I'm going to say here. I'm going to read this backwards. I want factors of 80 that subtract to give me 2. So I want 2 numbers that are going to multiply together to give 80, but they must subtract to give 2. 10 and 8, okay? Now, but I don't in fact want 2, I want minus 2. So the bigger one must go with the negative sign. Okay, and now this is factorized, and I'm going to get my answers of minus 8 or 10. Okay. Your answer is the same. Yes, the ones you got from the quadratic formula. 100%. No problem. I'm just thinking, thank you. Thanks, my letter from Jabula. I'm just thinking that maybe it's easier to do this than the quadratic formula. Maybe not for you, but how do you get better at factorizing? By practice. Okay. I want you to write this question down just while we talk about factorizing. Everyone try this one. And I know this wasn't a question on the sheet, but I want us to talk about this one. I also want us to talk about this one. Yes, guys, this is so important. Looking for an answer for the green one when someone's got one. I know I don't want to rush you because some of you need a bit of time, but and after the green one, I'm looking for an answer for the blue one. Okay, I'm just asking you to factorize them. I haven't left enough space for the answers, but to factorize them. Thanks, Camilla. Yes. Yes. I'm going to ask you to look at that. So if I've got that, must I have two different signs, one positive, one negative, or two signs that are the same? Two signs that are the same. And when I have two signs that are the same, they must both be what this one is. So straight away here, these must both be pluses. Okay. Okay, this is not going all that well. It doesn't factorize. Okay. But it does. Sorry, it does. Okay. Okay. Yeah. Carry on. Do you know what the factors of 24 are that add to 11? 8 and 3. Does it matter which one I put where? No, because I've got plus signs, it doesn't matter which one's in. Okay. All right. Keep the microphone. Hang on to that microphone. I want you to tell me now about this one. An X and an X. Must I have two signs that are the same or two signs that are different? The same. Okay. And when the signs are going to be the same, they must both be the same as the first one. Yeah. So as soon as you look at a quadratic equation, look at the back sign, the second sign. If it's negative, you're going to have different signs. If it's positive, you're going to have the same signs and they will be the same as that sign. Right. Now, I want factors of 24, two numbers that multiply together to give 24, but they must add to 10. 6 and 4. And does it matter which one I put in? No. Okay. Now, all right. Now I want us to look at D. In English, and my pen was playing up, so I didn't write it out in full. In English, sometimes we say, look before you leap. Look before you leap means don't rush into things. I'm wanting someone to tell me a quick, clever way of factorizing this. Okay. I'm not wanting you to multiply this 5x into the 2x plus 3. So anybody want to tell me, yeah, right at the back row there, thanks. And guys, man, Camilla was a humble Manji, okay? Just now she needs to go to be with her own children rather than with the 200 children here, not children, young adults here. All right. Okay. Yes, tell me. Of what? Halala. Guys, do you see that that is a common factor? Okay. Take it out for me. Tell me what it's going to look like. Well done. How easy is that, guys? Okay, very nice. Yeah. All right, guys. Here at Michael House, I've got the very top set in grade 11. Okay, this year. I promise you, they're 30 boys. It's a big class. Okay, it's a big class for my class. It's probably not a big class for the schools. A lot of you are in classes much bigger than 30. But for my class, 30 is a big class. I reckon 29 of my boys, they will multiply this whole thing out and then they'll factorize it. Because they're not looking carefully at it first. Okay, now it's factorized. What do we know? We know either this bracket is 0. So in other words, 2x plus 3 must be 0. Norma, 1 plus 5x must be 0. Now we've still got equations to solve, but these are simple ones, eh? What should I do to both sides first? Yeah. Minus 3 from both sides. 2x equals minus 3. Let's do this one at the same time because we're so clever, we can do 2 at once. What should I do here? Minus 1 from both sides. What should I do here? Divide by 2. What should I do here? Divide by 5. Oh, goodness. -1 over 5. Okay, and there's our answers. Right. I'm not going to do lots of these, but it is about practicing. Okay, guys, I haven't had a chance to do a memo for this workbook. Last week I gave the teachers a copy of the memo. All right, I will try and do a memo for this as soon as possible, and I'll send it to your teachers. Okay, I just ran out of time. Okay, I'm going to skip to exercise 3. All right. And so I'm on now, guys. I'm now on page 12. Okay, and I'm very aware that we're not even halfway through the book. Okay, so okay. So this is page 12. You must go. Yeah. Maybe, guys, I don't know if there's one of the teachers in the room who wants to walk around with a microphone for me. That's great. Thanks so much. Guys, maybe we can just thank Ma'am Camilla because she's going to be going out. Thanks so much. Right, guys, this is now working backwards. We want to create an equation which has got these solutions. Anybody want to tell me? Maybe you can just put your hand up. There's and the teacher will come to you. So I want you to think about working backwards. What would, and it must be an equation. I've got to have an equal sign, otherwise it's not an equation. And I'm going to put a 0 there because it's to get this product. What must go inside these brackets? Yeah, so over here's somewhere nice and close.
X minus 30.
Yeah. Well done. And now they might ask for it in standard form. They might say multiply it out. Let's just quickly multiply it out. Yeah. Yeah. Okay, I'm combining those two into one. Yeah. Yeah. Equal to 0. Okay. And there it is. That's my equation. All right. I want you to try B. Now, all of you try B. Just try on your own because you've seen sort of what we've got to do here. But this one at the front, I want a coefficient of x squared equal to 3. But get the equation first, and then we'll talk about it. Yeah, so we got a volunteer. Yes, thank you. Yeah, ready? Is it not working? Is it working? It's working? You don't want to do it? You're looking for someone else? Okay. Someone else? Anyone else? Okay. Yeah. No? Yes? X minus 3. Well done. Equals 0. It's got to be equal 0. Okay. Right. Now this equation works. I'm going to multiply it out. It's going to be x squared It's going to be plus x minus 3x. It's actually going to be minus 2x minus 3 equals 0. This is all good. I've done all that. Cordwa, I haven't done this. Now, I want a 3 here. So what should I do to get a 3 here? Multiply by 3, but I need to multiply both sides by 3. What's 0 times 3? 3. And I also need to multiply this by 3 and this by 3. And there is an equation which has those roots and it has a coefficient of x squared equal to 3. Right, because we can multiply both sides of an equation by anything without destroying the balance. Right, now we're going into the next page. We've got some quite, they look a little bit scary, okay? Right. Now, what's making this question scary? The fractions. What could I multiply by to get rid of the fractions? Yeah, if I multiply by x minus 2 and by x minus 3, the fractions will disappear, am I right? Which side must I multiply this on? Well done, on both sides. On both sides. So let's try and do that now. Let's see what will happen. So I want you to picture this yellow stuff, and I want you to picture it over here, multiplying there. And remember, it's on top. And then I want you to picture it over here. It's on top. And then I want you to picture it over here. It's on top. Who can tell me what will the first term be on the left-hand side here? What will I get when I multiply by x minus 2, x minus 3? Yeah, here we go. Someone's got his hand up. Just sorry. I don't, in the same row as you, this guy right here, right? No, put your hand up again. This guy over here. Yeah, no, he had his hand up. He's put his hand down now. Okay, put your hand up if you're confident. Yeah, okay. Have a go. Just if you get it wrong. Okay, it's better to try and get it wrong than to not try. Yeah, grab the microphone. There's there. Thank you.
Are you going to be there for the X?
Well done. Keep going because you know what you're doing. All right, just guys, the slowly, is it okay with that? What's happened is the x minus 2's have divided out, leaving the x minus 3 and the x. Okay. Now, what's going to happen here? Yes. And then here? Okay, halal. I want you to ask yourself now, is this better or worse than it was? It's much better. It hasn't got fractions. It's still got brackets. So what must I do now? Carry on. You've got the microphone. Yeah. Yeah. Well done. Yes. Okay. Yeah. Okay, he's minus 3 from both sides, yeah. Okay. Talk to me about the signs. The signs are the same, guys. Remember, I know I'm slowing you down because you know what you're doing. But if this sign's positive, the signs are the same, and they are the same as that sign. So those signs are both negative. Okay. Factors of 6 that add, sorry, factors of 8 that add to 6. 4 and 2. So now x equals 4 or 2. Okay. Now, well done. Very well done. Cordwa, and I'm just, before let's clap. Okay. But, okay, we must, when we've had fractions, we need to check, all right, because if x equals 2, we get division by 2. We've got a restriction here. X is not allowed to equal 2, all right. And the reason x is not allowed to equal 2 is because we would have a 0 underneath, 0 underneath. It's easy to remember, underneath, undefined. Okay, you try 2 divided by 0 on your calculator, you'll get an error. Okay, you cannot divide by 0 in maths. So check, x is not equal to 2, therefore the final answer is x equals 4 only. Okay, well done. Guys, I'm not going to do lots of these, because just remember, when we've got a fraction, we must check. And I've taught in my career, I've taught some very very clever boys. Boys that have got out of 150 on the final examination, they've got like 149 out of 150. And do you know where they lose the mark? Here's where they lose the mark. They forget to check. It's easy to forget. So we're not going to do this next question, but I am going to just write here before we even start this question, just check. Okay. All right. I am going to also show you one other thing about this question. What would I need to multiply by here to get rid of all these fractions? And the reason I'm asking this, guys, x minus 2 and 2 minus x. Can anybody tell me, how can I simplify my life so that I don't have to multiply by x minus 2 and x minus 3 and 2 minus x? Yes, over here. Yeah, so there. Okay. Just have a look at this. I'm going to write down, I'm not sure what you're going to tell me, but I'm hoping what I might tell you. Tell me what to, yeah. Okay.
Equals to 1/3, 1/3 minus 2/6.
Okay, hello. Okay, now guys, what I want to show you here is what's your name? Sorry. How to say it plain for me? Menezes. Okay, Umi. My hearing is not good. What you've done here, very nicely. All right. I don't know the name for this in maths, okay? But I call it a switcheroo, okay? Because what we're doing is we are switching, okay? I call it a SIMI switcheroo, but there it is, okay? What we've done, we've changed this from 2 minus x to x minus 2. Cordwa, you can only do that if you change the sign in front, okay? Now, I think you'll agree with me, this is easier because what am I going to multiply by to get rid of the fractions? An x minus 2 and an x minus 3. Okay, I just want to quickly talk about this little switcheroo thing. If you've got 5 minus 2, what's the answer? It's 3. If you've got 2 minus 5, what's the answer? A negative 3. Okay, so if you've got a minus b, that will be the same number as b minus a, but it'll be the negative. Okay, and I want you to look at what's happening here. If we multiply this negative 1 in here, what do I get? I get a negative b, and I get positive a. It's the same thing. Okay. Where it becomes very useful is in factorizing or even in simplifying. Look at this. What's the answer to this? X minus 3 divided by 3 minus x. I cannot cancel these x's or cancel these 3's. Have you still got the microphone there? Take it back. Take the microphone back. Just tell me how. I want you to switcheroo one of these. Doesn't matter which one. So what I'm asking you, I'm going to leave this as x minus 3. I want you to tell me what must I do to make the bottom x minus 3. I must put a negative sign there. All right. Now, guys, can I now divide and divide? Yes, I can. What's my final answer? -1. Okay, allow. All right, guys, we're not going to do more of those. So I'm going to ask you to jump now to this question over here on page 14. Okay. Now, again, I'm going to write here, look before we leave. Right. If I multiply this out, if I square this out, I'm going to get x to the 4 whole. Magic yourself. It's going to be ugly. Okay. Can anybody tell me, and I'm sure some of you know, what is the trick that I'm going to use here for this question? Yeah, over here. It's closer. You can go to the back or here, it doesn't matter. You go wherever. Thanks. Okay, well then what does that mean? Okay, so we're going to let k equal x squared minus x. So if we do that and we write this equation out again, it's going to be minus, so k squared equals 8k minus 12. Okay? Have you got the mic? You want to carry on? You want to tell us what you're saying? Yeah. 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 Well done, guys. The signs are going to be the same because that's a plus, and they will both be like that. 6 and 2. So what is k? Or 2. Okay. Cordwell, we're not finished, are we? Okay, so we've got 2 more equations. Okay. Yeah. All right, see if you can factorize this first one for me. Talk to me about the signs. Will they be the same? They will not be the same. 1 plus, 1 minus. And this one? Not be the same. Okay? Well done. Well done. The bigger number is going to get the negative, yeah. 1. Final answers, all 4 of them. Well done. Excellent. Okay, guys, we're not going to do all of them, all right? But if I let this be k, so maybe you can just underline or put a circle around it. If I let that be k, will the equation look better or worse? I think it will look better. We're getting k minus 8 plus 12 over k equals 0. There's still a bit of a problem here because we've got fractions. What could I do? Multiply by k. All right. K squared minus 8k plus 12 equals 0. Guys, I'm not going to finish this question, okay? And the reason I'm not going to finish this question, I want us to try and do like a mix of different types of questions. This, just talk to me about the signs. If I was to factorize this, would they both be different? Well done. They would be the same That tells us that they will be the same, all right? And this tells us when they're the same that they're going to be whatever this one is. So they'll both be minus. Okay. Pendula ikasi, all right? And pendula ikasi futhi. Okay, now. I want you to write this down over here. Right. Yeah, let's guys, if x plus 2 equals 3, how many answers are there to that? Eleanor, just one, and the answer is 1. But look at this. Can anyone tell me, just by looking at this, what possible answers could x have? X could still be 1. But there's another answer now. What else could x be that would give us 9 when we add 2 and then square it? This one's only got one answer. This one underneath the red line has got 2 answers. And I don't want you to multiply it out and solve. I want you to think. Because I could have 3 inside the bracket, but I could also have what inside the bracket? I could have -3, guys. Do you agree that this yellow stuff, okay, I'm waiting for the pen to catch up. Do you agree that this could be 3 or it could be -3? Because if I square it, I'll get 9 anyway. And if it's -3, what must x be? -5. So when you square both sides, you're going to get more answers. Okay, and sometimes those answers aren't going to work. I want us to look at number 2. All right? Anybody want to tell me what I'm going to do with number 2? All right, I'm also going to ask someone to do number 3. Yeah, let's get someone else. Thanks, that was great. All right, what's the problem with number 2? It's got a square root in it. Okay, anyone want to tell me what we're going to do? Square both sides. Okay, I'm hearing square both sides. I like that, but just be careful because if you square this, you're not going to get rid of the square root. Funny enough, if you square it properly, you're still not going to get rid of the square root. Okay, no, people are volunteering their friends. Okay, thank you. All right, so we're going to add 1 to both sides. And now yeah, okay. And now what are we going to do? Yeah, what we're going to do now, guys, we're going to square both sides now. Yeah. Okay, so now, guys, this everything. Must the 4 get squared, or must the square root get squared, or must both get squared? Both. Remember this exponent rule that we did early this morning? A, B to the C. Which one gets the C? Both. Okay, so tell me what it's going to be. Yeah, carry on with the mark. 16. Yeah, she might be right yet, yeah. Not just +1. Otherwise, you're going to give me another round to make me a millionaire. Okay, guys, remember this is actually x plus 1. X plus 1. So x squared plus x plus another x plus 1. Halala. Okay, Is this better or worse than it was? It's much better. Carry on. Yeah. Right, carry on. Why don't we try and get a 0 on this side? Okay. Yeah. Yeah. Okay. It's 2x, and I'm subtracting 16x from which side? From both sides, guys. I'm subtracting 16x from the left-hand side. I'm also subtracting it from the right-hand side. Well done. Plus 33. I'm adding 32 to both sides. Okay. I want you to tell me how to factorize this. I want you to tell me about the signs and how you know what the signs are going to be. Well, very nicely explained. The signs are going to be the same because the last one is positive. And what are they going to be? Are they both going to be positive or both negative? They're going to be the same as the first one. Yeah, they're both going to be negative. Now, I want factors of 33 that are going to add to 14. I'm hearing an answer over here. Someone's helping me over here. 11 and 3. So my answers are x equals 3 or 11. Now, code one. When we square both sides, we must check, because remember what I showed you here. When you square both sides, you introduce an extra answer that wasn't necessarily there. Okay, let's put 3 in here. 3 minus 2, 1, square root of 1, 1, 4 minus 1, 3 equals 3. This is cool. Let's put 11 in here. 11 minus 2 is 9, times 3 is 4. This 4 times 3 is 12, minus 1 is 11, it's also 5. Okay, all right. Now, sometimes one of them won't work. In this one, they both worked. I want all of you just to quickly try this one. Okay, but don't square both sides before you have isolated. Isolate means got on its own. Get the square root on its own first. But don't forget at the end, I want you to check your answers. Okay, thank you.
I propose the look of the situations one
So did you add one to both sides? Tell me what you write. Okay, so you said -1. You said -1 plus x. Guys, would you be happy that I also could say x minus 1? Yeah, it's the same thing. You actually haven't transposed the 1. You've actually added. You've transposed the negative x. I prefer we've added x to both sides. Okay, now tell me what happens when I square both sides here. Yeah. So you carry on. I'm listening to you, and I will write it down. I'm just waiting for my pen to catch up with me. Okay. All right. So tell me what it is. 2x plus 1. 2x plus 1. So you've squared the left-hand side. Now you've got to square x minus 1.
to x plus 1 equal to open brackets negative 1 of x close open negative 1 of x.
Okay.
And 2x plus 1 equal to 1 minus x plus x squared. And x or 2x plus 1 equal to 1 minus x plus 2x squared. And as a story, and I'm putting 2 squares, minus 2x.
What did you get? X squared?
X. Let's go X.
I don't think it's plus 2. I actually think it's x squared minus 4x. Yeah. It's x squared minus 4x. Okay. Now we must factorize. Okay, guys, please don't click. Okay. Now we must factorize what? X and x minus 4. So my answers are 0 or 4. Okay. Hold on, I must check. Let's just check. When I put 0 in, guys, when I put 0 in here, I get 2 times 0 is 0 plus 1. I get the square root of 1, which is 1, minus 0. I get 1 equals minus 1. That's in Kega. That does not work. Let's try putting 4 in. What's 2 times 4 plus 1? 9. Square root of 9. 3. Take away 4. Negative 1. Yeah. It works. Okay. So just be careful because we've got to check. Okay, guys, I'm going to go onto page 18. All right. And you know what? I'm going to. Sorry, guys. Sorry. I know I'm going to do just question. I'm just going to do this question on page 17. All right. Now, again, this question here, if I asked you to solve it, listen carefully here, guys, because this might be the first time you understand this. If I asked you to solve it, you could square it out and try and factorize it. That's not the quickest, cleverest way, because at the moment, x is only in one place. So the easiest way to solve this equation is going to be to add 12 to both sides. And now I'm going to square root both sides. When I square root both sides, what must I remember? I can have plus or minus. And what's the last thing I need to do? I need to add 4 to both sides. Okay, there are my two answers. I could work them out on a calculator, but I don't need to. Okay. All right. So I want us to now, I'm going to give you just a few seconds to copy that down. Then I want you to go to page 18. Go to the next page, page 18. Okay, and guys, I want you to take this down, right? Because do you agree? Quite a few times today we have squared things, like x plus 1 all squared. So I want us to just do a couple of these just to see. When I square a plus b, who can tell me what's the final answer, simplified answer of a plus b all squared? What is it? A squared plus ab 2ab plus b squared. Okay. I want you to make sure you've got that written down and maybe underline the 2. Because now I'm going to do a different one. I'm going to do p minus q all squared. And I want us to look at what we're going to get. We're going to get p squared. Then we're going to get pq's, but we're going to get 2 of them, negative 2pq. And we're going to get q squared. And again, I want us to look at this 2 there. Right. I'm wanting us to look for patterns. Maths is all about patterns. Look at what we've got. We've got the first thing squared. We've got the last thing squared. And then we've got the product, a times b, and we double it. Here we've got p squared. We've got q squared. We've got the product minus pq, and then we double it. So now, and now you're going to think, oh, Paul is now, he's tired, he's lost it completely. I want you to write this one down, and I want you to tell me what is it going to be. Okay. Oh, man, my pen is just jamming. Okay, guys, I'm waiting for my pen, which is really irritating. Okay, what I told the grade 12s last week, guys, listen carefully. When this happens, you know what I want to do? I want to take this computer and like punch it. I want to punch a hole in the screen. Okay, but I'm not going to do that, right? Because one of the things about being a decent human being is having self-control. Okay? From a Christian perspective, self-control is one of the fruits of the Spirit. Okay? I'll tell you what they are. They are joy, peace, love, patience, kindness, gentleness, faithfulness, patience, and self-control. And at the moment, I'm needing to be very patient because my computer is irritating me. Guys, have a look at this. Ikaya plus inflancy. Okay, that's not a very good fish. I'm going to try and draw it again. Ikaya plus inflancy squared. What is it going to be? Ikaya squared plus 2 Ikaya inflancy plus inflancy squared. Okay, and I want us to highlight the 2. I'm going to do one more. Ebola, right? Plus, I don't know, lightning bolt. Okay, what's it going to be? In fact, guys, sorry, guys, this one I'm changing something here. I'm going to make this one minus. Okay. Ebola squared minus 2 Ebola lightning plus lightning squared. Okay, now, the reason I'm showing you this, we want to be able to go from the right-hand side to the left-hand side. Watch, I'm going to try and solve this equation. This equation does not factorize. There are no factors of 2 that multiply to give 6. This process I'm showing you now is so important. So we're going to spend a little bit of time on it. I'm trying to get x equals. Do you agree? Quite a clever idea would be to add 2 to both sides. Because there's no x here. Mind you, Nancy Kinga, x is in 2 different places. If I could write this like that, x would only be in 1 place. Now, let's think about what we're going to need here. And all these ones that I did on the right-hand side here, I did them for a reason. Do you agree I'm going to need an x? Now, listen carefully. Listen very carefully. Whatever I put here is going to multiply with x, and then it's going to double. So what must I put here so that I get 6x? I must put 3. Halala. The reason I must put 3 is because of these 2's. Okay. Now, when I multiply this out, do you agree I'm going to get x squared? I'm also going to get 3x doubled, which is 6x. What else am I going to get? 9. 9 Kinga, because my scale was balanced, I need to add 9 to the right-hand side. Do you see that when I multiply this out, I'm getting 9 on the left-hand side that was not there? Okay, look at my scale. Because I've changed the form, I've added 9. So how do I fix that? By multiplying by 9. Now, I want you to look at line number 1, and I want you to look at line number 2. Remembering that I'm trying to get x on its own. Over here, x is in 2 different places. Kodwa, over here, Elilodwa, x is only in 1 place. So now x plus 3 all squared is 11. Let's square root both sides. Square root of 11 plus minus. And finally, let's subtract 3 from both sides. Minus 3 plus or minus the square root of 11. Guys, this process is called completing the square. What did I do from the 6 to get to the 3? I halved. Why did I halve? Because when I square out a binomial, I end up with a doubling. And that's why I halve. Does it make sense? It always makes sense. Okay. I want us to try yeah, let's try C. Okay. Now, the first thing, I don't want a number in front here. So if there's a number in front here, I'm going to divide everything through by 2. X squared minus 2x. Now, I hope you're okay with what I'm going to do here. Equals to 5 over 2. I've done 2 things at once here, now I'm sorry for that. I've added 5 to both sides, and I've divided everything through by 2. Okay, now, and I'm gonna give you a minute or 2, okay, just to think about what must I put. I don't want you to shout it out. I want you all to think, what must I put in here, and what must I add on here to keep this thing kind of all balanced. Okay. Okay, guys, I'm going to show you just, I've just seen some pictures on my phone. I'm just going to share them with you and show you. Maybe I'm not looking on the phone. That's it. Right, so right, guys, there are some of the other schools, all right? So that's a school called Georgetown. There is Edendale Tech. It's a big school. Igusasiliche. All right, and I'm not sure, also Igusasiliche. Okay, so they are joining us online. Okay, right, now, like to tell me what, and I'm hoping we've got our microphone somewhere. Yeah, okay, great, thank you. What am I going to put inside here? And the pen's going to walk about, as it does. Right. Well done. Okay, just wait 1 second. My pen's trying to catch up with me. X minus, sorry guys. Okay, just carry on talking and tell me what, yeah, that's right. And guys, just think about, remember when we were squaring the fish and the lightning bolts and Ikaya? If I square this out, what do I get? I get x squared. I get negative 2x. What else do I get? 1. So carry on talking to me, yeah. Well done. I'm going to add 1 here. Okay, well done. And guys, the big difference, all right? The big difference between this line and this line is x is in one place only. What happens when I add 5 over 2 and 1? Now, think about 5 over 2. We can't add it to 1. Can you make 1? Tell me what sort of fraction must I make 1 into? Yeah, halala, 2 over 2. Okay, so in fact, I get x minus 1 all squared is what? 7 over 2. Okay, so what will x minus 1 equal? Into the microphone. This square root, yeah, square root 7 over 2. And my final answer